Do you smell that? Yeah, what is that? I think it's the smell of change. So there's definitely been a growing need for reliable and portable astrophotography equipment, especially when you are transporting, setting up, and tearing down your equipment. Being able to do so in record time is truly second to none, especially when you're trying to escape light pollution for dark skies. So in this video, we're taking a look at the AM5 harmonic mount from ZWO. It's a lightweight and portable equatorial mount that does not require a counterweight and has a high payload capacity. Along with being an equatorial mount, it can also operate in alt-azimuth mode. So if you like to observe the planets and do astrophotography, then this makes it a very versatile and portable mount. So in this product review, we are going to take a look at what came in the box. I'm then going to go over the features and specifications of the AM5, and then I'm going to share a little bit about my experience while testing the AM5 and whether or not I would recommend it. So without further delay, let's get to it. So as I mentioned, the AM5 is a lightweight harmonic drive mount. What exactly is a harmonic drive mount? Well, inside of the body of the mount here, it uses a mechanical gearing system that uses harmonic drive technology, or sometimes referred to as strain wave gear technology, to control the axes of the mount. And what's unique about harmonic drive technology is that it can handle a lot of weight despite being in a smaller package without the need of a counterweight and without needing to balance the axes for tracking accuracy. This is going to be a lot different than what we see with worm gear technology, which is very prevalent in today's equatorial mounts. And they definitely do have their pros, there's no doubt about it, but the mounts are going to be a lot heavier and they do require a counterweight to function. And you do need to balance the axes to ensure tracking accuracy, or else you're going to add strain to those gears and you are going to mess up the accuracy of the tracking capabilities of that mount, which is no bueno. So it does make a lot of sense why we are seeing more mounts with harmonic drive technology in them. This is the first time that I've ever used a mount with harmonic drive technology in it, and so I wanted to thank ZWO for the opportunity to test and review the AM5. I did test it with different optical payloads, as well as at different exposure lengths, as well as during different seeing conditions. That's just because a lot of things go into what determines the quality and the performance of a mount. So I did try to control for a lot of those different factors. And so as always with any review that I ever do, all views are completely 100% my own. And so with all of that out of the way, let's see what came in the box. So inside of this box, we have the mount, so let's open it up. Okay, so inside of the box, we also have this white box. It has a nice feel to it and has a carrying handle. Now let's open up the box now. Inside we have the AM5 quick guide setup, and we also have this mount's performance sheet, which I will go over in a little bit. Okay, so we have this really nice hard shell cloth carrying case. It has this cool space art design on the front, and it also has two zippers and a handle on the top. Let us unzip the zippers. We have an M6 Allen key, and we also have an M4 Allen key. Next we have the hand controller and the hand controller cable, and we also have a 2-meter USB 2.0 cable. Next we have the Holy Grail, the AM5. Overall, everything fits in this carrying bag, which is really rad. Also no counterweight kit, so no counterweight bar or counterweights, which is also quite crazy to me. Okay, so now let's dive a little further and go over the features of the AM5 in more depth along with the specifications. The body of the AM5 weighs 5.5 kilograms, or about 12 pounds, and the maximum payload capacity without a counterweight is about 30 pounds-ish, or 13 kilograms. So think a small to medium-sized refractor, or a Schmidt-Cassegrain telescope. If you do want to increase the payload capacity of the AM5, you do have the option for that. You just need to add a counterweight, and then the maximum payload capacity increases to 44 pounds or about 20 kilograms. And from my understanding with the use of a counterweight, again, it's not necessarily to balance the axes themselves like you would need to with a more traditional equatorial mount. It's more so just to make sure that everything is upright or stays upright and doesn't fall over, which would be a good thing. So whether you end up using a counterweight or don't use a counterweight, you still don't need to balance the axes like you would with a more traditional equatorial mount like an EQ6R Pro mount. The strain wave gear technology in here doesn't have any backlash, so you don't really have to worry about it. So I did briefly touch on this point, but harmonic drive technology isn't new. It's been used in applications like robotics, in aerospace. It was used in the Apollo lunar rover, just as an example. It's just only recently that we're seeing harmonic drive technology be used in telescope mounts. And I think that's in large part because we as amateur astrophotographers are really looking for the same level of functionality, but with more portability in our equipment. And so ZWO designed their strain wave gear inside of the AM5 to have low periodic error. So on average, the AM5 has a guiding accuracy between 0.5 and 0.8 arc seconds of total error. If you're not familiar with what periodic error is, it's basically a small mechanical error in the tracking accuracy of a mount. And so you, of course, would like to have a periodic error that is very, very small, because the guiding error or the periodic error is going to cause issues with the tracking, which would then mess up the exposure or the long exposure. So having a very low periodic error is muy bueno. And so each AM5 mount comes with its own test report here. I will zoom this in so you guys can actually see. It can be accessed via the QR code here at the top. The first graph I'm going to go over is the full periodic error in arc seconds over a 360-degree displacement. The 360-degree displacement down here on the x-axis is an important figure to call out because ZWO discovered that what we normally refer to as periodic error is actually not very periodic at all, like how you would see with worm gears. The error of each gear for harmonic drives is different from one another, and so they decided to test the full periodic errors of each mount. And so a full period would rotate the mount 360 degrees in 24 hours for one reducer rotation, thus giving you a more accurate representation of the mount's performance. So down here on the second graph, here is the individual's mount partial zoom of max periodic error with the same labels for the X and Y axes. What you're seeing here is just a small portion of a segment from the full periodic report above. And so if we make our way back up here to the top of the page, we have the summary. So you can see when the test report was generated, you have the serial number of the individual mount, and you also have the maximum and minimum periodic error of your specific mount. All right, let us proceed to some of the other features of the AM5. Like I mentioned briefly, the AM5 can function both as an equatorial mount as well as an alt-azimuth mount. So if you are an astrophotographer who also enjoys observational astronomy, this mount can do both. And so there is a little light indicator here on the front plate of the mount. The red light is going to indicate that you are in equatorial mode. If it is green, that means you are in alt-azimuth mode, and you can use the hand controller to switch between the two. So this is the ZWO AM5 hand controller. It does emit its own Wi-Fi, and it is web page managed, meaning that you can do all of the firmware upgrades for the hand controller here as well as the AM5 through the hand controller. ZWO also developed an accompanying application for the hand controller because, as you can see here, there isn't a screen like you would normally see on a, probably your more traditional hand controllers. So through that application that you can download to your mobile device, you can do your go-to functionality. You can see what targets are in the night sky. Again, you can also upgrade the firmware, and you can also switch between the two modes of the mount, so between alt-azimuth and equatorial. And I probably would only ever use it if I was doing observational astronomy or to take flats with outside, which I don't do anyways. Also, I would probably use it just to make sure that the optical train doesn't hit any of the sides of the tripod first before I slew it to a target. And so that's why it's going to be really important if you do have a longer refractor, which I will show you what I used in a little bit, to use the pure extension here. You can't really actually see it, but yeah, you just don't want to have your refractor hit any of the sides of your tripod. That would be bad. So yeah, again, I probably wouldn't use the hand controller really for anything else except for if I was doing observational astronomy, or if I just wanted to make sure that my optical train did not hit the sides of the tripod, or for sky flats. So that's that. Okay, now we are ready to dive into some of the hardware specifications in greater detail. Starting at the top here of the mount, we have a dual standard saddle with aluminum clamp knobs. The dovetail is suitable for Losmandy and Vixen designs up to 500 grams. I personally like this feature a lot because it's just more versatile. The tension knobs here are really smooth and easy to use, as well as strong. On the other side, we have the mounting hold for a finder shoe, and below that we have the power switch. So once you are connected to power, you just press this button and you're ready to go. Here on the front plate of the AM5 is where the 12V in is. It's for a 12-volt power supply port. And next we have the hand controller port. Since I don't really use the hand controller, I just leave it disconnected. Moving on, next we have an ST4 guide port. I wouldn't recommend using the guide port just because you should always guide directly with your guide scope. Next we have a USB port for connecting the mount to the ASI Air or to another computer with ASCOM drives to control the mount, if that's what you want to do. And next to that, again, here is the status light indicator to indicate if it's on or not, and if so, which mode we are using. Again, the red is for equatorial mode, and the green light indicates that it is in alt-azimuth mode. On the other side, we have a DC outlet socket for powering accessories like the ASI Air, and a finder shoe to mount accessories to the side like a laser pen or an electronic polar scope and camera, since the AM5 does not have its own polar scope. You can also polar align the AM5 through the main imaging camera if you have the ASI Air, for example. On the back of the mount, we have two bubble levelers. I can never say that word. We have two azimuth adjustment knobs, and we have an altitude adjustment grip. These are all really easy to use and really does make polar alignment more precise, at least from my experience. The machining quality of the AM5 is just very evident in the smoothness and the accuracy of these knobs and grips. Next, we have the latitude scale. It has an all-around 0 to 90 degree pitch angle. Last piece I would like to point out is the option for a counterweight. If you are going to use an optical train heavier than 30 pounds, then use a counterweight less than or equal to 5 kilograms. The counterweight should be secured on a counterweight bar of no more than 25 centimeters in length. Okay, moving on to the tripod. The AM5 is designed to fit the carbon fiber tripod from ZWO, the TC40. However, the AM5 can be used with other tripods as it has a 3/8 inch screw mount on the bottom. You would want to use heavier tripod legs with very large optical trains. I did add a counterweight to the pouch down below for when I was imaging, and it worked like a gem. And overall, I really like how easy it is to use the tripod and how lightweight it is. You can also change out the feet of the tripod with these dirt spikes or dirt spokes. As you can see, the tripod is fairly short, which gives the entire setup a low center of gravity, which does make it quite stable. However, like I mentioned before, it does run the risk of having longer optical trains bump into your tripod legs, which you definitely don't want. So using a pier extension like I have here can help you avoid that, and it can also give you more time imaging before a meridian flip. This is the ZWO PE200 pier extension option, which has a load capacity of 50 kilograms and weighs 1.6 kilograms. And installing it is really easy to do, and it's compatible with the ZWO carbon fiber tripod. as well as other 1.1 inch steel tripods from Ioptron and Skywatcher, and with the 2-inch tripod for Celestron advanced VX mounts. If you're looking for an even more portable option, ZWO has the PE160, which has a 3-pillar pier extension option that you can also purchase in addition to the PE200. The carbon fiber tripod and pier extension are also sold separately. The ZWO TC40 tripod mount comes with the tripod, of course, comes with the tripod head plate, the leg spreader, the leg spikes, and the weight bag. And at time of filming, the cost of the TC40 is $299 US, not including shipping. For the PE200 pier extension, it comes with M6 screws and a Skywatcher adapter plate. And so at time of filming, the PE200 without shipping is $169 US. And if you want to remove the sides of the PE200 and replace them with the 3 pillars for a lighter setup of the PE160, you can purchase those separately for $40 US. You're probably also wondering how much the AM5 is as well, and so at time of filming it is $1,999 US. Now, for the price to load capacity compared to the overall weight of the AM5 and compared to other harmonic mounts out there on the market, that's just very competitive. So now let's check out the results from my tests. So now let's get into what my testing experiences were like. I did use different optical trains with the AM5. I also used different exposure lengths, and I also tested during different scene conditions. I did also use the AM5 with and without the pier extension, but to control the mount and during my entire imaging acquisition sessions, I only used the ASI Air Plus. I'm just a big fan of the ASI Air Plus. I'm really just a big fan of the entire ZWO ecosystem. I think it makes astrophotography a whole heck of a lot easier, and I've been using it for over a year, so for whatever that's worth. I mean, literally from electronically assisted polar alignment to go-to functionality to tracking to just setting up your image plan and beyond. It's just a really nice little tool. If you're not going to use the ASI Air, it is compatible with ASCOM drivers, or does use ASCOM drivers. So yes, now let's go into the optical trains that I used with said AM5. Okay, so the first optical train that I used is this here. The telescope is a William Optics RedCat 51 refractor. It has a focal length of 250 millimeters. And then the camera here is a ZWO ASI 533 MC Pro color camera. I did guide, and I used a William Optics 50mm guide scope here, and the guide camera is from ZWO. It's an ASI 290mm Mini. So with this, I actually didn't use the pier extension because it's just such a small optical train, and it worked just fine. So here you can see that I imaged the Andromeda Galaxy, I imaged the Orion Nebula, and I also did image the green comet that just passed by. So here are all those images, and the stars are really pinpoint. These are just raw images. They're not stacked or anything. I haven't done anything to them. And that's considering, and well, let me back up. That's let us consider that the stars here are actually not the most or the best sampled pixels that you could ever see, because just given the focal length of the RedCat paired with the sensor size of the 533, I'm definitely very oversampled, so just taking that into consideration. But guiding was fantastic. And so of course I was imaging these targets, well, the Orion Nebula and the Andromeda Galaxy, when they weren't necessarily closest to the zenith. And so I did image them all throughout the night. So from their highest point that I could at least see from my location to the horizon, and guiding was consistently really good, anywhere between 0.5 and 0.9, which again, I'm imaging from a balcony, which is not the most stable place to be imaging. So I was very surprised that the AM5 was able to guide as well as it was. So yeah, that's that. Now let me put on my other optical train for you. I will be right back. Okay, so this is the second optical train. I'm gonna stand back here so we can all fit in the frame together. I might be out of focus, so I apologize. But the refractor here that you see is a William Optics Fluorostar 110. It has a focal length of 770 millimeters. The camera that I'm using is the ZWO ASI 2600 mm Pro. It's a monochrome camera with a ZWO 7-position filter wheel here with filters and such. I have a Bader Planetarium steel track focuser here, and I did guide with a William Optics 100 millimeter guide scope and an ASI 174 mm mini guide camera. I did image the Fossil Footprint Nebula. I will show you a raw photo or a raw sub here. It is a very, very faint nebula. And so I did use the pure extension, and I also used the, what is it called? The TC40 carbon fiber tripod. Inside of the little weight pouch, I put one of my counterweights from my Skywatcher EQ6R Pro down below, just to make sure that it just kept its balance like you would with other tripods. And yeah, guiding was surprisingly good. So the Fossil Footprint Nebula is not very high at the zenith either. And so as it moved throughout the sky, the guiding actually stayed pretty consistently good. Again, anywhere between 0.5 and 0.9. I did see it inch up over 1 arc seconds of total error, but it was very windy that night. I actually also did see the guiding get close to 0.4, which I was really amazed by. It could have just been when I just dithered. But other than that, I've just been very impressed with how the AM5 performs. Again, I am imaging on a very unsturdy balcony next to a highway and a train, which is wild. And this really did perform really well. You can see here in the stars, they're pinpoint. I, again, have been very impressed overall. Here are just some guiding photos that I have of the guiding that I took. And yeah, overall, so I might be a little bit out of focus right now, but I'm just going to do my concluding remarks with the FLT refractor in place. I do really appreciate the fact that I was able to try out the AM5. I think it's a fantastic piece of equipment, especially from a portability perspective, and I didn't even go to a dark sky. I probably can speak for a lot of astrophotographers out there when I say that, you know, sometimes we just cannot be bothered to set up our equipment. I'm only going a few feet outside when I set up most of the time, and even then I just don't even want to break my back. Even though I do love my existing equipment, the AM5 really is a game changer in the department of portability, and the accuracy of the AM5 is also just top notch. And so the build quality and the price point, I am just very impressed, as well as the versatility of the AM5. I really don't have any thing that I would change about the AM5. I do think that it's just a great option for amateur astrophotographers out there. And so if you have any comments or questions, please leave them down below. And as always, I really do appreciate all of your support. I hope this review was helpful wherever this review takes you in your astrophotography journey. And until the next video, I hope everybody here has clear skies.